Hello everyone. So welcome to APEX-GPAT. Uh, Today we are going to talk about the previous year GPAT questions from the pericyclic reactions. From the pericyclic reactions, on an average, every year one question is 100% it is coming. Okay. So if you are perfectly study the pericyclic reactions, you will get the +4 marks easily. First, we will see what is the questions asked in the previous years. In the GPAT 2015, there is a one question, which diene can undergoes the Diels-Alder reaction. First, understand what do mean by pericyclic reactions. Pericyclic reactions. You know that the peri means number one. One means here it is the single. So these are the single step reactions. The single step reactions we also call it as the concerted reactions. What we say this one? We say it as the concerted reaction. The meaning of concerted single step reactions. There is no mechanism involved here. Here mechanism means only transition state. What it makes the difference between the pericyclic reactions with the other reactions? Other reactions having the mechanisms, step 1, step 2, step 3, these are the different steps we have. But when we are talking about the pericyclic reactions, here we don't have these mechanisms. These are the single step reactions. We say it as the concerted reactions. Out of that, 3 types of the pericyclic reactions we have. In that, one of the pericyclic reaction, Diels-Alder reaction. Diels-Alder reaction. Diels-Alder reaction, it is come under the cycloaddition. It is come under the cycloaddition reaction. Understand the fact, cycloaddition means, yes, we are adding the 2 things and we are making the cyclic compound. That is what here we say it as the cycloaddition. What we say here? Cycloaddition. We are adding the 2 things and we are making cyclic compound. But the question is, what are the 2 things we are adding? Yes, the 2 things here we are adding. One is conjugated diene. Conjugated diene. Other one is dienophile. Might you will get confused. Dienophile means, simple language if I want to say, it is the alkene. When we are taking the conjugated diene and dienophile, and if you make the cyclic compound, that is only we say it as the cycloaddition. In that cycloaddition, one of the reaction is the Diels-Alder reaction. Okay. Now we will understand what is the conjugated diene. Can anyone tell what is the conjugated diene? Yes, you are correct. The conjugated diene. The conjugated diene means alternative double bonds. Alternative double bonds. Remember, if the reaction wants to go for cycloaddition, Diels-Alder reaction, the 2 things are important here. One is the conjugated diene, other one is the dienophile, that is the alkene. Now, what do you mean by conjugation? The conjugation means alternative double bonds. Conjugation means alternative double bonds. Double bond, single bond, double bond. You look at alternative double bonds we have. This is what we call it as the conjugation. And we have the 2 double bonds here. That's why we say it as conjugated diene. Conjugation means alternative double bond. And here we have the 2 double bonds. That's why we say it as the conjugated diene. Let's say that. This is the conjugated diene. Do you observe here conjugated diene? Yes. Double bond, single bond, again double bond. Here we have the conjugated diene. Okay. Now what is the question is asked? Which diene can undergoes the Diels-Alder reaction? Which diene can undergoes the Diels-Alder reaction? Right? That is the question. First option, 1,3-pentadiene. What is the 1,3-pentadiene? We will write the structure. 1,3 pentadiene. Penta means how many carbons? 5 carbons. 1, 2, 3, 4, 5. These are the 5 carbons. 1, 2, 3. This is the first carbon. This is the third carbon. In the first carbon and third carbon, we want to put the double bond. In means double bond. Di means 2 double bonds. Where we have to keep the 2 double bonds? 1 and third position. This is the first position and this is the third carbon, and we put the first and third carbon double bonds. Make it valency satisfy. Did you observe here? 1,3-pentadiene. So look at 1,3-pentadiene. This is the structure. Now look at this structure. Do we have the conjugation? Here there is any involvement of conjugation? Conjugation means what? Alternative double bonds. Do we have alternative double bonds? Double bond, single bond, double bond. Yes, we have the alternative double bonds. Conjugation is present here. Conjugation is present here. We will take the option B also. In the option B, what is there? Option B, 1,2 butadiene given. What is the 1,2 butadiene? We will write the structure. Meth, eth, prop, but. This is the but. First carbon and second carbon. Double bonds. I put the double bonds here. Make the valency satisfy. CH2. Here already carbon valence is the 4. Valency satisfied. Hydrogen and CH3. This is the 1,2 butadiene. Now we will see, do we have the conjugation or not? Double bond. Again we got the double bond. There is no single bond in between 2 double bonds. Do we have the conjugation? No, we don't have the conjugation. What is the conjugation? Double bond, single bond, double bond. This is, we call it as the conjugation. Do we have the conjugation? No, we don't have the conjugation here. No conjugation. Because double bond, it started immediately. Now let's see that option C. Option C, what they have given? 1,4 pentadiene. What is the 1,4 pentadiene? Penta means how many carbons? Again, it is the 5 carbons. 1, 2, 3, 4, 5. That was the 5 carbons. Now, diene, but this diene on what position? 1 and 4th position. 1, 2, 3, 4. This is that. And here we have the 4th position. This is the second carbon. This is the third carbon. This is the 4th carbon. This is that. Look at. Now observe, do we have the conjugation or not? Double bond, single bond, single bond, double bond. What is the conjugation? Double bond, single bond, double bond. This is the conjugation. But here what kind of arrangement is there? Double bond, single bond, double bond. Here we don't have the conjugation. Here we don't have the conjugation. Now we'll see that option D. In the option D, what we have? 1,4 cyclohexadiene. What is the 1,4 cyclohexadiene? Hexa means, obviously you know that fact. Hexa means it is the 6. The 6 carbons are present in the cyclic form. We will write the 6 carbons. So this is the 6 carbons. It is present in the cyclic form. Now what is that? Diene. But where the diene is present? 1,4. First carbon, second carbon, third carbon, 4th carbon. I put the 1,4 cyclohexadiene. Now look at, do we have the conjugation or not? Do we have the conjugation or not? Obviously, if you observe very carefully, double bond, single bond, double bond. Double bond, single bond, double bond. This kind of the arrangement is present here. Now tell me, is it conjugation is present here? What is the conjugation? This is the conjugation. But here also conjugation is not present. Here also conjugation is not present. I already discussed in the starting only. Diels-Alder reaction, you require the conjugated diene. 1,4 cyclohexadiene, in the option D, we don't have the conjugation. 1,4 pentadiene, we don't have the conjugation. In the option B, 1,2 butadiene, we don't have the conjugation. In the option A, 1,3 pentadiene, yes, here we have the conjugation. So answer will be option A. So answer will be option A. Just a tick mark that answer option A. I think you all are understand how to rule out the option when they ask the diene regarding question. Clear everyone? Okay. So which diene can undergo the Diels-Alder reaction? The answer is the 1,3 pentadiene because conjugation is present. Just observe conjugation is present or not. Conjugation means double bond, single bond, double bond. Present is or not. Just observe. Then 100% you will get mark. Okay. Let's move to the next question. What is the next question? In the GPAT 2016, there is a one question is asked. This is that. The question is like this. CH3 plus COO CH3 COO CH3, and we have to identify the product here. These are the options we have. Option A, option B, option C, option D. But how to rule out the option? How to rule out the option and how to maintain the stereochemistry we will understand. If you observe all options, they have given the stereochemistry point of view. Look at below the plane, above the plane, stereochemistry was given. Now how to solve this question, we will do that one. Okay. Diels-Alder reaction. Again, this question from the Diels-Alder reaction. If you observe, CH3 plus COO CH3. Okay, this is the question now. Now, in this question, we want to identify the product. First, we will understand what is the Diels-Alder reaction. Again, I said Diels-Alder reaction means the reaction between the two things. What is the two things? One is the conjugated diene. Look at double bond, single bond, double bond, conjugated diene. Other one is the dienophile. This is the dienophile alkene. So this is the reaction is occurring in between two. Now the product is forming. Normally in the Diels-Alder reaction, what is happening? There is a formation of two new sigma bonds, or there is a breaking of two sigma bonds. That is what going to be happen in the Diels-Alder reaction. Let me take a small example, then we will solve our question. First thing, do we have the conjugation or not? Observe. Do we have the conjugation? Yes, conjugation is present. Double bond, single bond, double bond. Conjugation is present here. This is the dienophile alkene. Now, how the reaction is occur? The reaction is occur. Look at. Just rotate the bonds. This bond is moves here. This bond is moves here. And this bond moved on the first carbon. Okay. Now what is occurring? This is the what my basic skeleton. I have written basic skeleton. Now this double bond moves comes here. These pi electrons are moves on here. Now these pi electrons are moves on this carbon. Look at. And these pi electrons are moves on this carbon. Look at. Now only this single bond is present. That is this. Okay. What we got here? Cyclohexene. Cyclohexene. But understand here, the sigma bonds formation here. Look at, this is the one new sigma bond formation. Here one new sigma bond formation occurred. This is that. And this is the one more sigma bond formation occurred. This is that sigma bond. How many sigma bonds are formed here? Yes, the two sigma bonds formed here. The sigma plus 2 we say. And this is the reversible reaction. This can break also. These sigma bonds can break also. That's why we can write sigma minus 2 also. So the grossly we can say Diels-Alder reaction delta sigma plus or minus 2. What is that? Delta sigma plus or minus 2. That means two new sigma bonds can form or two new sigma bonds can break. That's why we say it as the delta sigma plus or minus 2. That is what the Diels-Alder reaction, cycloaddition. Okay, clear? Now come to our question. What is asked? This is our question. Just rotate the bonds. Just rotate the bonds here. This bond moves here. This bond moves here. And this bond moves here. Now what is the product? Yes. This is my basic skeleton. This pi electron moved here. New sigma bond. This pi electron moved on this carbon. New sigma bond. Now what is there? Rest of the this moiety is pending. Yes, this is this bond. What is pending here? COOCH3. Here what is there? COOCH3. And alternative what if we have? Double bond here. That is that. And these pi electrons are moved on this carbon. Here also double bond. Rest of the things we have the CH3, CH3. Okay. So that was the product. Simple. Just to rotate the bond. Whatever the end pi electrons are there, this moved on this carbon. उसके बाद a pi electron move करो. This pi electron moves on this carbon. That is what happening here. Very simple reaction. But the question is what asked? They asked about the stereochemistry. We want to identify the stereochemistry. Now the question is what? Stereochemistry. Remember, in Diels-Alder reaction, the two types of the stereochemistry format questions will be asked. The two types of the stereochemistry format questions will be asked. What is that? One is that stereochemistry of adduct. Adduct means product. Stereochemistry of product due to stereochemistry in the dienophile. The stereochemistry of the product due to stereochemistry in the dienophile. That means this is the my dienophile. This is my product. Okay. The dienophile suppose having the cis configuration. And my product also having the which configuration? Cis configuration. Let's say that my dienophile having the trans configuration. My product also having the trans configuration. That means simply it is following the stereo-specific reaction. The dienophile configuration and product configuration will be same. So one thing, the product stereochemistry due to stereochemistry in the dienophile. If you know dienophile content is the trans configuration, our product also content is the trans configuration. Our dienophile content is the cis configuration, our product also content is the cis configuration. Understand fact here. Here, the configuration will be same. That is only we say it as here stereo-specific reaction. What we say? Stereo-specific reaction. Okay. Now what is the trans and what is the cis? How you will represent trans and cis in stereochemistry here? Look at the two types of the bonding present here. Two types of the bonding present here. What is that? One is below the plane. Other one is above the plane. One is below the plane, other one is above the plane. You all know the below the plane we represent this bond, dashed bond, below the plane. Above the plane we represent, that is the wedge bond. Below the plane we represent the dash bond, and above the plane we represent the wedge bond. This we say it as the dash bond, this we say it as the wedge bond. Okay. Now, if the two substituents, we are writing the below the plane, that means the two substituents we are writing in the dash form only, or the two substituents we are writing the above the plane, that means we are writing in the wedge bond. If the two substituents are below the plane, if the two substituents are above the plane, here the two substituents must be same. Two same substituents are writing in the below the plane, two same substituents writing in the above the plane, then you say it as the cis configuration. What we say? Cis configuration. On the other hand, one substituent you are writing in the below the plane, other substituents you are writing in the above the plane. That means, suppose substituents are the hydrogen. One substituent you have written in the below the plane, one hydrogen you written as the below the plane, other hydrogen you written as the above the plane. That configuration you call it as the trans. Okay. Or else one substituents you have written as the above the plane, other substituent you have written as the below the plane. Let's say that hydrogens only. One you have written above the plane, other you have written below the plane, then also we call it as the trans configuration. दोनों same में लिखो, cis configuration. If the two substituent you have written as the opposite way, that was the trans configuration. That was the basic concept. Now what is our question? I said the stereochemistry due to dienophile, I said. Stereochemistry due to dienophile, I said. Let's say that this is the compound, my diene, and here I am having the dienophile. This is my dienophile, but this dienophile contains the substituents. What is that? COOCH3, acetate COOCH3, hydrogen, hydrogen. This is my dienophile. This is my dienophile. These are my substituents. First we will write the product, then we will see the stereochemistry. What is the product I said? First move this bond here, move this bond here, and move this bond here. Then you will get the product. This is the basic skeleton. I have written the basic skeleton. This pi electron moved on this carbon, it forms the new sigma bond. This pi electron moved on this carbon, it forms the new sigma bond. Rest what we have? Single bond. And what we have here? Yes, we have the COOCH3, COOCH3, H. This pi electron moved on this, here pi bond. That was the product I got now. Okay, that was the product I got now. But I want to write the stereochemistry. That means this substituent, I have to put it as a cis configuration or a trans configuration. Below the plane or above the plane. Very simple. Look at our dienophile. This dienophile is present in the cis configuration or trans configuration. Can you tell me? Trans configuration? No. It is not trans configuration. It is the cis. Q? Same substituents. देखो, same substituents present in the same plane. देखो. And here two same substituents present in the same plane. If the substituents are present in the same plane, that we call it as the cis. If the same substituents are present in the same plane, we call it as the cis. If it is present in the opposite direction, we call it as the trans. It is present in the same direction, it is the cis. If it is present in the opposite direction, we call it as the trans. So this is the cis. Our product must be cis only, because Diels-Alder reaction follows the stereospecific reaction. So our product must be cis only. What I said cis means? What I said cis means? Yes. The two hydrogens put the below the plane, or the two acetate groups put the above the plane. That we call it as the cis. Same substituents, same plane, below the plane. Same substituent, same plane, above the plane, cis configuration. Or else you can write other format also. The two acetate groups put the below the plane, or two hydrogens put the above the plane. This is also we call it as the cis configuration. This is also we call it as what? Cis configuration. Let me write the product now. Yes, this is my compound. Hydrogens, here I am putting the first one below the plane. Hydrogen, both hydrogens below the plane. Acetate, COOCH3, above the plane, both are above the plane, cis configuration. Or other format, how the product can form. This is my compound. Now the hydrogens I am going to write. What is that? Hydrogens above the plane. Above the plane. And here acetates I am going to write below the plane. You look at, this is also we call it as the cis. This is also we call it as the cis. Both are in the cis configuration. So the product may be this one or this one. Okay, clear everyone? Clear everyone? If I want to write it as the trans, how it will be there? Suppose trans I want to write. You can write like this. One hydrogen below the plane, other hydrogen above the plane. One you write it in the below the plane, other you write it as a above the plane. So this we say it as the trans configuration. What we say? Trans configuration. Let me write one more example to make it more clear. COOCH3, hydrogen, COOCH3. This is my diene, this is my dienophile. What is the product? You all know the product is this one. This is the product. COOCH3, hydrogen, COOCH3. Yes, that is what happening. Now the question is, what is the stereochemistry? What is the COOCH3 and hydrogen presence here? Cis configuration or trans configuration? Yes, it is the trans configuration. That means our product also trans configuration. Let me write the trans configuration now. Hydrogen, COOCH3. Okay, here hydrogen, COOCH3. Look at, one hydrogen below the plane, other hydrogen I have written the above the plane. One COOCH3 above the plane, other COOCH3 below the plane. The opposite planes, the both are opposite planes. The same groups are present in the opposite plane. That's why what we call here trans. What we call here trans configuration. Or else you can write it in the format also. What is that? COOCH3. COOCH3 below the plane. Here COOCH3 above the plane. Here hydrogen above the plane. Here hydrogen below the plane. This is also what we call trans, opposite planes, trans we call. Because whatever the dienophile we have here, the dienophile also present in the trans configuration. That's why our product must be trans. Now, this is the one type of question can come in your exam. But in the 2016, they asked the question second format. They are not asked the question based on the dienophile. I already discussed initial only. One is the stereochemistry of the product, due to dienophile. Okay, due to dienophile. Other format, the second type of the question, the stereochemistry of the product due to, what is that? Yes, it is the diene. एक dienophile का सबसेट, दूसरा diene का सबसेट. What is the diene? You know that this is the diene. What is the substituents? These are the substituents. Let's say that here hydrogen we have, here hydrogen we have. Here one more substituent R, here one more substituent R. This is my, what is that? Diene. Double bond, single bond, double bond. This is the what? Diene. Now the question is what? Observe very carefully. This hydrogen, the both hydrogens are present in the outside. This we call it as the outside group. किसका outside था? Diene का outside था. Right? These hydrogens are present outside of the diene. This is the diene, outside of the diene. This is also outside. This is the R group, this is the R group. The both R groups are present inside. It is present inside of the diene. These are the outside, these are the inside. Okay, this is the clear? Inside means this group, outside means these groups. Now, Diels-Alder reaction. In Diels-Alder reaction, the outside substituent of the diene, whatever the outside substituents are present, these outside substituents always below the plane. Always below the plane of the product. Whatever the outside substituents are there in the diene, whatever the outside substituents are there, these outside substituents always write it as a below the plane in the product. Below the plane in the product. In the Diels-Alder reaction, whatever inside groups are present, in diene, these you write it as a above the plane in the product. Outside diene, below the plane, inside diene, above the plane. Okay, that is the basic thing you remember. Okay, above the plane and what? Below the plane. Now come to here. If the same groups, suppose hydrogen and hydrogen, both are the same groups. The same groups are present in outside. Then you say it as the cis. What do we say? Cis configuration. Same side, cis. If the same groups present in opposite side. Opposite side means one hydrogen is outside, other hydrogen is inside. The same group, one hydrogen is outside, other hydrogen is inside, then you call it as the trans. Okay, the trans means one hydrogen outside, other hydrogen is inside. In the other format, I can write the cis. What is that? The same groups, that is the hydrogen and hydrogen, it is present in the inside. If the same groups are present in the inside, then also we say it as the cis. If the same groups are present in the outside, cis. If the same groups are present in the inside, we say it as the cis. If one hydrogen is outside, other hydrogen is inside, trans. The same groups, one is inside, other is outside, we call it as the trans. Let me take the example. Okay. R, R, H, H. You look at here, hydrogen, hydrogen, hydrogen and hydrogen, it is present in the outside. Outside both groups, we say it as a cis. R, 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 same groups present in the inside, we say it as the cis. This we call it as the cis-cis. What do we call this one? Cis-cis configuration. Cis-cis configuration we say. दूसरा एग्जाम्पल मैं लेता हूं. Look at RH, HR. This is the diene. Hydrogen outside, hydrogen inside. What we say? Can I say cis? The same groups are present on the same side. The same groups are present on the same side. You tell me. No, it is not present in the same side. That's why we call it as the trans. Here also R inside, R outside. We call it as the trans. This we call it as the trans-trans configuration. What we call trans-trans configuration. You tell me, Diels-Alder reaction follows the what type of the reaction? It is the stereospecific reaction. What do you mean by stereospecific reaction? If the diene having the configuration is cis and the product also having the which configuration? Cis only. If the diene having the trans, the product also having the which configuration? Trans only. That is what the stereospecific reaction. Now we will see that our question, what is asked in our exam. Our question is CH3, CH3, COO, CH3, COO, CH3. This is our question. Now you tell me, both methyl groups are present in where? Inside or outside? Yes, outside. Yes, outside. You know that the both methyl groups are present outside, right? If the both same groups are present in the outside, what is the configuration we say? Cis or trans. The same groups are present same side. Cis or trans. We say it as the cis configuration. Now what is the product configuration you are going to expect? Obviously, product also we are going to get the cis. Product also we are going to get the what? Cis. But in the starting of the question, I discussed at one point, if the groups are present in the outside, what configuration you have to write? If the groups are present in the same side, what configuration you have to write? That means opposite side, what configuration you have to write? What configuration? Yes, we have to write that. हम लोग already पढ़ाई किया था. Outside diene, if the groups are present outside of the diene, below the plane. If the groups are present inside the diene, above the plane. Okay? Outside, below the plane represent, inside, above the plane represent it. So my question is, if these groups are present outside the diene, outside of the diene, what configuration are you going to write it here? Below the plane or above the plane? Yes, below the plane. What was that? Below the plane. We will try to write down the product now. This group moves here, this group moves here. This is the Diels-Alder. Yes. And here what is that? Double bond. COOCH3, COOCH3. Now the both groups are present outside. What we write? Below the plane or above the plane? Yes, below the plane. Below the plane. I have written the both are below the plane. That is the dash line. And other thing, If you observe, this is the cis. My product also what I got here? Yes, my product also cis. My product also what I got here? My product also cis here. That is what the GPAT 2016, what is the question is asked. Now you can select the answer. What is the answer? Yes, option B is your answer. Cis, both are the cis configuration. Okay. So thank you everyone. If you like it, share, subscribe and inform to all your friends also. Thank you so much, and we will discuss other questions in the next video. Thank you.